Hello, I want to talk about API testing, and I believe this part might be a little bit long because I plan to start from scratch, like even the basics, the brief explanation of the API, and then I will go over different API types, and eventually I will go through several ways to perform our API queries, which will include several tools, including Postman, and even maybe we can do some coding practices as well to perform our queries, and of course collect the responses. So first things first, starting from scratch, like what is API itself? As testers, we are trying to ensure the quality in the applications or the systems that we are developing, right? And what is the basic functionality of these systems or the applications? They have some different interfaces, which gives the users the chance to communicate or interact with the application. Like there are some users using the application. So in a way, they should communicate with these applications. So there are different ways, there are different interfaces to perform these interactions. So depending on the profile or the role, like if we are talking about real users or like end users, most of the time this interface is a UI, which is the user interface, right? But if the user is not a real user, but maybe another application, so sometimes the applications talk to each other. Like there are several deployed applications, or maybe there are different components of a huge system, which are the subsystems. They are communicating to each other. So in this case, the interface between different components or different applications is the API, which is namely application protocol interface. So, but eventually, we are talking about a client server architecture for sure. Like there is one side performing the requests to the server, and server is responding to these clients. And we can consider like this server as the application which is being developed, and clients most of the time are not only one user, right? There are several users which are sending requests. This is why we are performing a performance test as well on top of the functional tests. So this is the first thing that we can consider, the client server architecture. And if we are testing the applications that we are developing, of course we mock the client side, right? We simulate the requests coming to our servers. So we try to ensure that the application or the server manages or handles this request properly and returns the correct or the proper response. So we will see what kind of request we can send, or in other words, what kind of request the server can handle, and what kind of responses it should send to the clients, which means in what ways it should respond to the clients. So we will see the structure of the request and the response, like what kind of context we should have in our requests and responses, and maybe how we can understand if the request was performed successfully, or maybe sometimes there were some different cases where for some reason the request was rejected, and the relevant response would be returning to the clients. But moving forward, we can consider one more thing, the uh, detailed structure of this communication, right? Because, okay, we have two different interfaces, basically, but in the underlying structure, of course, starting from even the physical layers, there are several layers that we have to maintain. Let's a little bit uh, see this, and then we will continue with the types of APIs. So now when we are talking about the layers, of course, it is called as OSI layers, the OSI model, which is basically 7 different layers. So we are starting from the physical layer. Like, first of all, of course, we need the physical environment. Like maybe we need a device, which can be a PC or a smartphone or anything else, by which we will send our request and we will collect the responses. which means we will perform our communication, right? We try to interact with the servers, but first of all, we need the physical environment, like even including the cables or anything else. And but nowadays, not necessarily cables. Most of the time, we have already the wireless communication, but this is also the physical layer. And then we will have a connection to the server, right? If we want to communicate with the server, then we need a connection, which means an Ethernet uh, or a switch by which we will orchestrate our traffic or the network communication, because otherwise we cannot send our request, or we cannot listen to some certain path to collect the responses. And then after having this, we need the network layer, which means basically the IPs. IP is the address. Like if we have this already data link, like including several nodes which will communicate to each other, when we try to send our request to a specific node, we should know its address, right? In this network, we will send our request to a specific node, but how can the modem or the switch knows to whom we are intending to send our request? So for this, we need a unique address, which will be the address of that specific node. So this is basically the IP, Internet Protocol address. And then after having this, we can perform our transportation. This can be in different protocols, like maybe TCP or UDP. The basic difference between these two are when we are performing UDP, the server doesn't care if the client already captured the request or not. But in TCP, it always acknowledged the data which is sent through different nodes are always acknowledged. Like the server will know if someone already gets the response or not. If not, it will get maybe some timeout responses or any other responses, but somehow it will know if the response already collect the data or not. But in UDP, like we can think about maybe broadcasting services, right? For example, whenever we are as a server, whenever we open a broadcast, we don't know how many people will listen or watch our data transportation. Maybe even zero, right? So we don't care. We just broadcast, and whoever wants to collect this data will already get them. Otherwise, still we will continue to send or transport our data. And then we will have our sessions, like whenever we have the connection, then we can start several sessions. We can start talking to them, and then we can close one session, and then we can open another one. Like we can think, we can relate this to communication to different people as we do in our daily life. Like I have a friend, I'm talking to him several times in a day. So now I have a little chat. So I had a session, and then later on in the afternoon I will have another one. So I'll open another session, right? So each session can have some custom context or a different structure, but we can for now consider like each session will be some different maybe ranges to manage our connection or the communication. And then after opening sessions, we will start sending or collecting the data. And how can we do that? We can again perform several protocols like maybe encoding our data or even maybe encrypting, right? We can send our data in different ways. We can compress the data and then send, or encode, decode. We can perform several data operations. So all these kind of things are the presentation layer. And finally, we will have the application. Like what kind of application we will have? If it's a web application, it will be most probably the HTTP or maybe HTTPS, which is a secure version. Or maybe if it is a file or application, file-based application, it might be FTP. But eventually, after having all these layers, we will start our application. Like let's say it's a web application, so it will be HTTP or HTTPS. And then while communicating to this web application, we can perform several operations. Like for example, if it is a a web application which is broadcasting a media, then we may apply MPEG or JPEG is mostly for images, but MPEG protocol to manage our video data. Cool. So these are the basic layers which we need to perform our communication. All right, so let's talk about the API types. Initially, two of them were really dominant in the industry, which were the SOAP and the REST APIs. But recently, some new ones are also widely used, like GraphQL or some others. So first of all, let's discuss these two because they are very similar to each other, and then we can go through the rest of them. So the very basic difference between SWAP and REST APIs are the data type, which will be sent through our messages, the requests and the responses between the client and server. So in SWAP, it will be XML type. And in both SWAP and REST, we will need a URL or even a URI. We will discuss the difference between these two shortly. But we will need a unique address to which we will send our requests. So of course we will send the response request and collect the responses. So I want to show you a practical example. I will explain the usage of Postman as well, which is a tool, a very convenient tool to perform our API testing. So I guess I have it here. Yeah. So I have an open API which can do some calculations. So for example, this one is just doing the division operation. For example, I can send a request here to this URI. So this is the address that I will send my request. So in request, we will discuss the structure of the request and the responses, right? So don't worry about this. But basically, we will have some headers and the body inside the request. And in the response, we will say some other fields. So let's send, for example, 20, let's send 30 and 3. To this division operation. So when I send, I see the response in the below part. And what is the result? So the divide result is 10, right? So it's here. And I can see the status, which says 200, okay? So we will discuss the meaning of this status code. So this is a code showing the result. So even without seeing the details of the responses, from the code itself, we can already understand if it was successful or not very quickly. Cool. So we will discuss the details about this, but let's see the rest as well, and then we can move on to the GraphQL and the usage of the Postman. So in REST, we will have a JSON format data instead of XML. In SWAP, it was all XML type data, right? Both the request and the response we can see here. But in REST, we will have JSON type like this. On the slide, I have one example. And again, I have the address to send my request. And then I can see it is a get. Somehow, I'm doing a get operation. We will discuss what kind of other types of operations I can do. And in the response, I can see some details. I guess this is one API which is returning some weather information, I guess. So we will go through some open and example APIs, so through which we can do different queries. So nowadays, API is very important, right? For example, whenever we are developing an application, like if you are, for example, developing a mobile application, then in your application, you can show today's weather. So for this purpose, of course, you need this information from some resources, right? So some servers are already doing this, so publishing this information. So you can call their API. So in this case, you are the client, but you are the client as an application. You are the application that you are developing. And then as this application, you are sending the response. Sorry, you are sending the requests. and will collect the response. So this will be a basic example for an API, which is the application protocol interface, the communication between two different applications. Otherwise, if you are a real human, you can just open the UI of the weather of information, right? I can just open my browser and see what is the weather information. But in application point of view, of course, opening a browser is not the case. So you will just send your request. So this is what we have the API interface. And REST is the acronym for representational state transfer. And we already discussed we need a unique address. And this is the request and the response structure. So let's move on. So let's talk about the difference between URI and URL. Basically, we need URI, which is built on top of URL. So URL is the address of the server, which is the first part of the whole URL. So URL is built on top of this. After the URL, we need some endpoints, which is basically composed of context and version and resource and the parameters. Like when you are querying for something, you can add some unique parameters. So in each time, you will have the relevant information based on your query parameters. So this is a whole URI. So in this way, we will send our request to these kind of URIs. And why what is the working principles of a REST API? It is basically stateless, which means what does stateless mean? Statelessness is the condition where you don't care about the previous communication, right? You can just start sending some requests or getting responses regardless of the previous ones. Like all the previous messages might be failing, or you don't have to know even about the situation of the previous messages. So you don't worry about the current state. You can just start communicating to the server from any state. So this is why we are saying it stateless. And again, of course, we will be sending the request and getting the responses. So basically, let's talk about the structure of this request and the responses. So on this slide, we can see an example request. So what kind of fields I have in my request? We already discussed that I need a unique address, which will be the URI, the request URI, and I should specify my request method, like what I'm trying to do by calling this URI. Am I trying to read some information, collect some information from the server? Or maybe do I need to update some information on the server? So this will be like posting something, or sometimes we will be like creating a new data as well. So these are all different types of operations. So we might even want to delete some data or information, right? So it will be a delete operation. So this is basically the request method. So which method or what kind of operation I want to do, I'm specifying with this method, and I'm sending my request a unique address, and I have some headers. So we will discuss for what purpose I can use the headers, and of course I have the body. But it depends. Like if it is a get operation, I might not need body because the body will be filled by the response itself because I want to read information. I don't want to send or create or update any information. So it might be empty for get operations, but it depends on the situation and the usage. But this is a very brief overview of the request. So let's discuss all fields one by one. The first one was the method, right? So what kind of operations I can have? We already see get is to retrieving some data. And a post is submitting an entity to a specified resource. And post, put, and patch. These three are very similar to sending some data to the server. Getting is the other way around, like reading some data from server. Post, put, and patch are sending to server, and delete is just trying to delete some specific resource. So what is the difference between these three? Post, put, and patch. Post is always for creating a new resource. Like if the resource is not there at all, then I will send a post. And patch is the other way around. Like, it is always for updating. If I know that the resource is already there, but I want to update some specific fields or specific part of the whole resource, then I will send patch. And if I don't care if the resource is already there or not, then I can send put. So how does it behave? Like, if I send a put request, first of all, it checks if the resource is already there. If it is, then it performs the update operation, because it doesn't have to create the resource from scratch because it's already there. But if it is not present when I send my request, then it creates. So put can be used for the other two, right? For either post or patch purposes. Post is for creating, patch is for updating, put is either post or patch. Cool. And then I have the headers inside my request, right? Why do I need some headers? It depends. Like, I might need it for different purposes. For example, I might want to inform the server about the data that I'm about to send, right? For example, I can say that, okay, I'm sending this request, but you will see this kind of information inside, or vice versa. Like, even the other way around. For example, I'm sending this information, but while responding, please send me this type of information, because otherwise I won't be able to understand. So this will be like the request related headers or response related headers, or maybe I can send some headers related to both the request and the response. So it will be like general headers. And even I can say something about data itself, which will be the entity headers. Like, for example, I can say that, okay, I'm sending information and you will see this length of information inside the body. So please be aware and please be prepared to get this type of, or this context of data in my request. So this is all the information that I'm sending about the data itself. It is not the body itself. It is just information about the data that I'm about to send. So we can evaluate these headers as the metadata to my request, right? So these are different fields or information about the data that I'll send. So some examples about the headers is, for example, the content type. Like in this one, I'm sending some information about the content that I'm sending. And the cookies or the headers, security headers are also attached in the headers. For example, if I need an authentication or authorization, that I'll send all the information with the relevant credentials or maybe token data inside the header. If I skip attaching this credential or a token, depending on the security way or type, then my request will be rejected, right? Because server will think that maybe I'm not authenticated or authorized. So we will discuss about the difference between these two as well. This is also important, being authenticated versus being authorized. But for this, I need to fill the token or the security related headers to my request. And then accept char set, it is related to the response, right? So whenever I'm sending, I will say to the server that I will accept this type of responses. So please be aware, if you send anything else, any other format, that then I'll reject. I will not accept that. So I'm already limiting the types of the formats of the responses that I will accept. And cache is maybe something that we can discuss shortly, but the cache information will also be handled or attached in the headers in my requests. So yeah, let's talk about caching, right? What does it mean? So when I'm talking to the servers or communicating to the servers frequently, sometimes each time when I query some information, sometimes it's not different, right? It's basically the same as the last response. So in this type of situations, we sometimes do not go to the server each time just to avoid having too much traffic. So what we do is we keep the information coming from the server in our caches, and if the information is already there, then we don't go the whole down to the server. We just read the relevant information from cache. But if, of course, we want to get the fresh information, although we have it, of course, we can disable, but otherwise, it will just enable us to avoid or just bypass going all the way down to the servers, just reading from directly from the caches. So it will be avoiding the network traffic, but instead we will read the information that we need from local resources. It's pretty convenient. And there are different types of caches, like that it can be local or shared. If it is shared, it will be stored in somewhere in the local network, but all the browsers or even different devices trying to query the same information can read this from the shared cache because it's shared among different browsers or devices. But in local, it will be only inside the browser. So whenever we are using a new browser, the request will be sent to the server all way down because it will not be found in the cache. And again, we can enable or disable depending on the situation in our request headers. All right, so let's summarize the structure of the request. We have the method like get or put post patch or delete, and we have the URI, and we have the headers and the body. For example, if we want to create an entity, of course, what kind of entity we want to create, we should declare this where inside the body. And what is the headers? All the metadata or the relevant information about the data itself. Cool. What about responses? Response, again, we will have some data which will be present in the body. So we can read the context that we are looking for inside the body. And similarly, we will have some metadata in the headers. And now we don't have the method anymore, right? Because response is a response. Like it will not be doing any operation as we do when we are sending the request. So we don't have such a field. It is not applicable for the responses. And we don't have the URI. Like there's no separate endpoints. Response will be just responded to the request owner. That's all. We don't need it. But instead we have the status. Instead of the URI and the request method, we have the status. As we briefly discussed before, it is just to quickly understand if the request was fulfilled successfully or not. By reading just the status, we can directly understand if it was successful or not. And of course, after that, on top of the status, we can investigate the details from the body. So, starting from the status code, this is the standard list of all the status codes. Like if it is successful, then it will be 200 for a general request. But of course, if it is a creation, which means the post request, then we will have 201. And if it is like an async request, then it will be 202. What else? Like I guess 204 was for delete request. It was no context, if I'm not wrong. And yeah, like 400 ones are very commonly encountered. Like 400 itself is the bad request. So if we miss some mandatory information or field in our request, then most probably we will have 400. Or if we type a wrong data format or data type, like whenever we need to fill some field with some string values, but we just put some integers, then we will have a bad request. And for security related issues, we will have 401 or 403, which will be authentication and the authorization errors. So let's discuss the difference between these two. This is because this is most of the time confused. Authentication is identifying the user, right? Which is sending the request. Like if it is not a registered user at all, then the server can say that I don't know you. Who are you? You did not attach your credentials, and I somehow could not identify you. So it is already returned by 401 response code, which is the authentication was not performed successfully. And authorization check is done on top of the authentication. Like even if a person can or is authenticated, he might not be authorized to do several operations. Like there are most of the applications are built by a role-based architecture. Like there are different roles or profiles. For example, the standard user can do different types of actions like read operations or maybe even write operations. But of course, the standard users are not wanted to perform all the actions like delete operations, right? Those kind of risky operations are done by maybe admin users or different profiles. So even though those default users are authenticated, they are registered, the system identifies them. If they send a delayed operation, the system will say that it is forbidden for you. Okay, I know you. I'm not giving you a 401. You are authenticated, but since you are not authorized to perform this operation, so I'm giving you a 403. There are several ways to perform our API queries, so I will show you a few of them. First one is a Swagger API. Uh, Most of the API developers use this because it gives you a chance to build your API endpoints, and in the meantime, we can test the API endpoints by using this Swagger API. So let's try a few of them. This is another example that we can use. So, for example, there are several endpoints here. Like this is the pet endpoint. This is this store. So this is just a Swagger pet store. And let's try to read some information about some pets. For example, if I pass some IDs here, then I can just execute my queries, right? Okay, I sent one get request to read the pet with ID 1. And what I get is, I get 404. This is one status code that we just discussed. It is used for not found responses, right? So pet with ID 1 does not exist. So let's see if they have with ID 2. It does exist. So the information is here. So we can see all the information regarding this pet. Its name is Golden Retriever. Sorry, its category name is Golden Retriever. Its name is Dola. Uh, Let me zoom in to better read. Yeah, and there are some other information as well. And we can actually let's try post. Like pet with ID number 1 does not exist, right? So let's try to create that. For example, if I set ID to 1 and this is my test pet, name is cute name. Okay, execute. I get 200. Should be there. So let's see. In my previous request, I get 404, right? So now what I will have, again, not found. But normally I had 200 here. So I guess we already found a bug on this Swagger, right? So, but this is the idea. Whenever we execute the request, then they should be properly handled by the server. Okay, let's see some other ways to perform our request. For example, the browser itself is actually for this purpose, right? Reading some information from the server. So, of course, while we are doing the post patch or put requests, we cannot. In a way, we can do that, but it's there is no straightforward to do that on a browser. But for get request, we can easily do that. For example, for this, what was the URI? It was this one. So let's just open. For one, we had some issues. For two, oops, even two is not there. Oh, I guess several people are using this in the meantime. So maybe some of them are already deleting this, right? So let's try to find some others. Like, how about one? Yeah, it's there. So it's not with the category name that I said, but I guess somehow some other person could do that. So this is the settings done by someone else. But yeah, I already could do my request with the browser itself, right? I sent my request and then I get the response. Actually, let me try to show you the network traffic from the browser. Let's inspect. Let's open the network tab here and let's query again too. So maybe so far already someone tried to achieve creating some pets with ID2. Who knows? No, not still there, but I can see my request here, right? So this is the get is the method of my request, and I can see the parameter here, and I can see my response as well. The status code for my response is 404, and I have the response headers, and even the request headers are there. And yeah, I can see some. This is the response context, and I can see some analytics like timings and everything else. So this is pretty cool. Like I can see everything going on. Like let's query for one more time. Oh gosh, it's deleted again. Yeah, since this is a public API, several people are using in the meantime. But yeah, this time I can see the new request and the relevant response. All right, these are already two using Swagger and browser. There is one more, which is the curl command. I already saw it here. So when I was getting the URL, you see this is the URL code or the command. So let's copy this. I can execute this from my terminal. Let's try. Here is my terminal. Execute and response is here. Okay, pet is not found, but still this is the response. So let's try one more. Like this time, let's try 3. It's not there. Yes, I found one. So this was the third. And then fourth is the postman. But I want to open a separate session for postman because I want to explain lots of things. But let me show you how we can do in our automation code as well. So let me open my IDE. It will be here. All right. Okay, I have an empty test here. Let's clear the previous comments and let's start writing our code. So for performing API requests, we can use several libraries or even frameworks. For example, the Playwright request library is one thing, or Exis is another library that we can use. But this time I want to use fetch, which is coming from the node fetch library. So I will send my request. So this will be an async request. So I add my await keyword and then I will send my fetch request. Then this is a promise. If I get this, then I will handle the response. So first, let's prepare our request. First of all, I need the URI here. Can I see the function parameters? Yes. Those are first URL and then the request init, which will be including some options for request. So what was my URI or URL if I don't have any other endpoint? Let me copy from here. It was this one, right? Yes. Okay. Okay, it's there. And what will be my request options? Like, first of all, I need to specify what kind of method I'm trying to perform. It will be get, right? I just wanna read the relevant information. That's all. And I guess it should be already fine. And then when I get the response, let's get its text. You see, I can call like this body status text, but for now, let's try to read the text inside. Okay. And if I can do that, then this will be my text. Let's just try to print in the console. And while doing this, if I have any issues, then just catch the error and print this. Okay. I don't know what will happen. Let's try. Playwright test, my test. Yes. It is running and yes, I see the response here. So this was already the fourth type. We performed our request from the Swagger, from browser, from curl command, and the automation. So the last and the fifth way would be using some tools. And my favorite tool for that is Postman. And let's discuss this in the next chapter.